Hello. Okay. Welcome. Welcome to Piano Tech Radio Hour. This is Ethan, your host, and I'm going to jump right in here because we're getting off to a slightly late start. We're trying to figure out some things around getting the message out today. I hope everyone got the message and the link for today. We got some feedback that maybe there was a glitch there, so apologies. But as always, we will have a recording. For today's session, a special treat. We're going to dig back into the archives and give you some content from the illustrious Del Fondrick, an icon of piano design. And, before we get jumped into that, for the folks out on socials viewing, I'll just give an intro to what we're up to here, Piano Technicians Masterclasses, Piano Tech Radio Hour, and then we'll dive right into some pretty cool content. So first off, would just like to say welcome to Piano Tech Radio Hour. Now, we gather here every Saturday to meet with and learn from the most fascinating and knowledgeable folks in the piano world, including manufacturers, rebuilders, musicians, makers of other instruments, and of course, piano techs. Our mutual goal is to become better at our craft, help each other, and to create an ever more musical world together. Piano Tech Radio Hour is brought to you by Piano Technicians Masterclasses, an online learning resource that brings you cutting-edge instruction from piano industry masters without leaving your home. You can find out more at pianotechniciansmasterclass.com. And what I chose to feature for today's session is some content from Del Fondrick, as I mentioned previously. Del has been with us for several sessions and always brings very interesting perspectives to the piano industry. Kind of one of those guys that's you might say is a little bit more thoughtful than the rest. He doesn't just take things for granted. He puts a little bit of a critical mind into, how pianos are designed and put together, and really tries to get to the first principles behind things. So I'll give a quick intro to Del, and then we will get to some of that content. So Del is a piano designer and builder. He's been actively involved in the piano industry since the early 1960s. Began as a piano technician doing basic piano servicing. Over time, he grew his business into a major piano rebuilding facility. He's been an active member of the PTG since 1972. He worked as a service manager for Oregon's largest Steinway dealer and continued as the official piano tuner for the Oregon Symphony Orchestra. Increasingly dissatisfied with the performance of new pianos, he began studying the design and manufacture of them, ultimately becoming director of piano research and development for Baldwin Piano and Organ Company. In 1989, he made another career shift, becoming, at the time, America's only independent design and manufacturing consultant. His first project was to design and build a 190 centimeter, 6'3" grand piano for the Charles Walter Company, followed by assisting the company in setting up their first grand piano manufacturing facility. 10 years later, he designed the Walter 175 centimeter or 5'9" grand piano. During the early 1990s, he designed and manufactured the 122 centimeter Fondrick vertical piano, that's 48 inches, which was labeled Revolutionary by Larry Fine in the Piano Book 3rd edition. Utilizing his patented soundboard system, patent 5320018, this piano has been called one of the best vertical pianos of its size ever built. A CNN video of this factory can be seen on YouTube. During 2008 to 2013, Fondrick worked with Young Chang, redesigning their entire product line and refining their manufacturing systems to improve build quality and performance consistency. Most of these new designs are now available in the United States and Canada. He's written extensively on the subjects of piano design, manufacture, and acoustics. He authored a long-running series of articles for the Piano Technicians Journal, The Designer's Notebook, that explained piano technology for the technician from a designer's perspective. He also updated and republished the historic book, Piano Tone Building, adding numerous footnotes and comments, correcting errors, and bringing the work up to date. More recently, he contributed to the book, An Introduction to Spectral Analysis Musical Sounds by David M. Koenig, Oxford University Press, 2014. And Fondrick lectures extensively on piano tech and design topics in the US, Europe, Australia, Korea, and China. In addition to his factory consulting work, he maintains several active research projects in his workshop, in Olympia, Washington. And as we view the content today, we'll be able to get a peek at his workshop in Olympia, Washington as well. And the first lecture I'd like to highlight is one where he covers the process of refurbishing old, cracked, and potentially completely useless soundboards with epoxy, a technique that he was basically the pioneer of. And several people have tried with great success. I really haven't heard any poor feedback on the process of refurbishing soundboards with epoxy. Most everyone I have heard of that's done it has had success and appreciated it. It is, according to Dell, it's kind of like a budget way to refurbish a piano soundboard, but it is actually quite effective. So let's take a look at that. We'll have a bite of about 15 minutes on that one, and then we will return to check out some of the other content I have on hand here.
And we can wedge the board up, we can do all this stuff, but filling that crack puts new wood right in the crack. We take their wedges out from underneath. We haven't altered the rest of this any. We've only altered this little bit. And there's no way that that's going to support any kind of crown. It just can't. So my thinking was, if we can't restore the crown in any way, what could we do that might still help the piano? And that's where I came up with this little bit. And the problem is not so much the loss of crown, but it's the loss of stiffness. Maybe we can put some stiffness back into the pen. So that's where I came up with the idea of an epoxy repair. And I will, on slide 27, some of the arguments about, well, I restored crown in the soundboard, and gosh, it really worked. It worked well. Its piano sounds a lot better. Yes, it does sound better. You replaced the strings, you cleaned up the bridges, you put on new hammers, you reset down bearing, you regulated the action. The piano should sound better, but it's not because you restored crown in the soundboard. All right. Ideally, in these pianos, we'd like to replace the soundboard. Good. So you've got a brand X piano out there, and the people like the piano for whatever reason. The monetary value is simply not there to replace the soundboard. I don't know the going rate for soundboards these days. I haven't done one for probably 15 years, well, 10 years anyway. But it's not cheap. So is the piano worth the expense? Well, perhaps not. Maybe the piano was never worth a new soundboard. Who knows? May not have been worth the soundboard that started out with. So that's that would be what I call the ideal solution, and I just ruled it out for a lot of pianos. So the not so ideal solution is to restore stiffness without restoring crown. Now, the first time I did this, I stripped the finish off the old board. I made it structurally sound again, and I just coated the top with, back in those days, I was using a lot of Guggen Brothers products, so I just painted Guggen Brothers epoxy all over the surface. I noticed that it was soaking into some areas, and some areas that I hadn't seen cracks in. You could see it was seeping into these little micro cracks. So I kept brushing over and brushing over and brushing over until it wouldn't take anymore. And I smoothed it all out and I let it cure, sanded it down, and put a coat of exterior varnish on it. And that was that. It worked. It worked fairly well. And I was happy with the job. And the customer was thrilled to death because she got her piano back, and it didn't cost her a fortune. But
Got a quick question in the chat
yes.
when you're ready. The question is, Diego said some brand new pianos have compression ridges, new from the box. What about that?
Well, I would make a note of them and leave it up to the customer and the manufacturer. Some manufacturers claim that that is a sign that the soundboard is working properly and that the correct level of compression has developed in the soundboard panel. I will simply tell you that when I described to Bruce Holdley, the author of the book Understanding Wood, at a convention that we both taught at, and we ended up having a beer together, and he asked me, he was puzzled, all this controversy, and so I explained the process that some manufacturers use, which is to dry the wood to 4% moisture content, glue it to ribs, and he did not believe me. No woodworker would do that. That's insane. I assured him that yes, this is exactly what they do, and his response was, well, how do they deal with all the cracks? How do they deal with the soundboard damage? And I said, they call it good. They call it, that's what it's supposed to do. He was horrified, as am I. No wood technologist would ever do that. So you get my personal opinion. My personal opinion is that this piece of wood, this sample is on its way to failure, and here's why. You can call it anything you want, but that soundboard is going to fail sooner or later. I would make a note, I would take pictures, I would have the client keep them. You're not going to argue with the company. They're going to tell you that they don't warranty that, but that's about all I can say. I don't have a solution. So we're going to keep using the ribs because we can't do anything about them really. Now, we are used to, we're used to dealing with wood structures like, solid wood structures and plywood structures, pieces of plywood. What can we say about plywood? If you wanted to glue up some plywood in your shop, what would you do? Well, you'd lay the one lamina that way, and you'd lay the next one that way, and then you'd put another one over the top like that. It's always balanced construction. Plywood always has an uneven number of lamina in it. Always. You always have one direction, next direction, and a third direction. So what we have here, let's picture that rib let's make that rib less tall and wider. Now let's make it less tall and wider still. at some point they'll meet in the middle. And now what you have is a 2-panel or a 2-ply laminate. Just like Mathysek used with his Equilibri soundboards back in 1880 something or other. And it was going to solve all of the known soundboard problems that had plagued the industry for decades. It didn't, of course, but that was the idea. And it didn't because it was a 2-ply laminate. So what we're doing here is we're keeping the ribs, of course. We're stripping the surface, the finish off of this, and we're going to put some epoxy on top. And what that epoxy is going to do, and I have not been able to get a good picture of this yet, but it penetrates the surface of this piece of wood. And depending on the density of the wood, it penetrates about half a millimeter to a millimeter. In some cases, if it's real tight grain, maybe a quarter of a millimeter. But it does penetrate the surface. And then over a period of time, it hardens, and this takes up to 7 to 10 days. And now what we have is a stress skin composite. What we've done is we have made this top surface.
Can you just say that term that you used one more time, because we lost you because you turned around? A stress something composite. What was it?
Stress skin.
Stress skin composite.
Yeah,
okay, thank you.
We've turned the top surface of this piece of wood into a separate skin, a laminate, if you will. And we've done very little to change the characteristics with the grain, but what we've done is we've made it much, much stiffer across the grain. Guess what? That's parallel to the ribs down here. That is essentially what we're doing when we treat a soundboard panel this way. If you look at a standard core this is a sample that I've done up for my other soundboard class on what we do, weird stuff. This is just a piece of spruce that I've glued up. It's quite thin, and it has a very thin layer of fiberglass cloth epoxied to each surface. Very tough, very rigid, stiff, dead stable, not going anywhere. 3 plies. And that's the key. That's the key to this system, is we're turning a 2-ply mechanical structure into essentially a 3-ply mechanical structure. Now, how do we do that? How does all this magic happen?
By the way, Cameron says, thank you for being prop laden today, Del. It is nice to see you describe and show all these various examples.
Well, you're seeing about half of it. I didn't want to keep everybody here for 4 hours. I'm slow enough the way it is. This stuff is used in boat repair all the time. And when I started fussing with this, I wondered how long it was going to last. And one of my boat builder friends, and this was in the 70s, and epoxies had not progressed to the state that they are in today. But he took me to an old boat that was sitting out in the yard someplace, pointed it out, and he said, well, There's a World War II minesweeper. Still floats. And surface is treated much like this. We will not be using epoxy. We will not be using a fiberglass cloth on this, which is often used in boat repairs, but we still will affect the upper surface. Okay, do I do anything with the bottom? Let's get that out of the way right away. What about the bottom of the panel? Because that's going to be just as ugly and just as messed up. And you run your hand over it, right there is compression ridge, right there is compression ridge. You can feel them. So am I going to do anything about the bottom? No, I'm not. Yeah, well, once we get all this done, I'll go down and I'll probably put some spray shellac to seal it, or spray varnish to seal it and make it look more presentable. Remember, these are typically budget jobs. You're trying to get the maximum performance, the maximum longevity for the least amount of effort and money for the customer. At least that's my approach.
All right. A very forward-thinking process that Del Fondrick put into practice here and graciously has been sharing with the community. The word has been spreading. I hear more and more folks working with epoxy on soundboards with good success. For those out on socials, checking this out, I will try to put the link actually in socials very quickly while we're on pause here. Our email service that's sending out emails, we're wondering if there's some type of glitch because it doesn't seem like the communication thoroughly went out today. So I apologize to anyone that wasn't able to attend. Glad we could bring a few of you on by giving you some messages that were functional. Let me, I'm just going to briefly take a minute to make sure I can grab this link and share it with folks out on social so they can jump on. And then we'll get to the next segment. The next segment is going to continue with the topic of soundboards, but dive a little bit more deeply into just the general design of soundboards with Del. And then after that, we'll hop into a lecture. So we're sort of going from specific to the general, just on general piano design. And that should take us out of today's session. And also, you can find these lectures on our platform if you want to dive deeper. And also, I'll provide a super secret spooky word later on. If you email me with it, I can give you a discount code if you're interested in any of these lectures. And so right here, I'm going to pop out the Zoom link for folks on socials. Glad to see you out there. If you do want to join us, you can jump in and join us for the rest of today's session. All right, let's hop on to the next lecture. Let me get it set up and we'll take a look. So this one is going to be on soundboard design, past, present, and future. And let me get that prepped up and we'll get ready to go.
As a 2-ply laminate. And any woodworker who has put much time and thought into this will tell you that a 2-ply laminate is very unstable structure. This is not exactly a new idea with me. I went looking and guess what I found? Matysiak came up with this idea in 1891. He came up with a lot of good ideas way back when. That is just one of them. let me back up. He came up with a lot of ideas. Not all of them were good. And this is one of those. His patent, if you can see on the drawing, shows a 2-ply laminate. And he makes some pretty interesting claims for it. It's not going to warp, it's not going to distort, it's not going to crack. It's going to do all these wonderful things, and probably this is the greatest thing that happened to the piano since, I don't know, maybe felt hammers or something. Of course, what he actually found out was that a 2-ply laminate, even if everything is touching, is unstable. That they're inherently unstable. And we as technicians know that because our soundboards in our modern pianos are essentially 2-ply laminates, and when weather changes, they change. They swell, they shrink, they do all kinds of weird things. Pitch goes up, pitch goes down. So what we would like is to make this assembly a little bit stiffer, and we'd like to have it act a little bit more like a 3-ply laminate. A 3-ply laminates are inherently stable, which is why you always find laminated panels for whatever they're going to be used for. Siding outside in the house, whatever. They're always an odd number of laminate. 3-ply, 5-ply, 7, 9, 11. They're always an odd number. That makes it an inherently stable structure. So if I can make in some way this a little more stable and a little bit stiffer, then I can make it act just a little bit more like a 3-ply laminate, and I can restore a little bit of the acoustical function of a nicely crowned, nicely stressed piano soundboard, newer piano soundboard. So this came up some years ago, in the late 1970s, early 1980s. Actually, I think around 80 or 81. I was getting ready to rebuild a piano. I was in the middle of rebuilding a piano for a woman. It was an early Steinway L that had come from, I don't know, Detroit or some city with a lot of temperature swings and a lot of pollution, and it was just the soundboard was a disaster. Cracks throughout. Needless to say, no crown. It was pretty bad. And so I had the piano in the shop and got the string frame out, got it all torn down. I was getting ready to kick the soundboard out, and I was debating with myself. It was getting late in the evening. Should I kick it out now just because it's fun, or should I wait until do it in the morning? So I decided to wait, went up for dinner, and as I was finishing dinner, I got a phone call from the owner. And she is highly stressed. It seems that her husband has run off with his 19-year-old secretary, and she no longer has the money that she had set aside for this job. Help, what can we do? She's an accomplished pianist and had taught piano in an earlier life, and that was, I need my piano and I don't have money for the new soundboard now. So I was interested in wooden boats at the time, and I'd been playing around with different ideas of using epoxy as a hardening and toughening process for damaged woods. So I thought about it, and I called her the next day, and I said, I have this idea. I don't know how it's going to work, I think it will work. This is what I'd like to do. We'll leave the soundboard in. We'll take it out. I'll sand it down or scrape it down and sand it and get it clean. And I'm going to coat the surface with epoxy. And we'll just see what happens. And I think it will do. I think it'll make it structured. It's not going to look as pretty as a new soundboard, but I think it's going to work. So I did that. And it worked amazingly well. It exceeded both of our expectations. Was it as good a solution as a new soundboard? I'd like to think not. I think I could do a better job on a new soundboard than that, but it was pretty good. One of the things I found out about the process as I cared for her piano over the next several years was that it required less tuning. Well, it required a lot of tuning because it was freshly strung, but it did not react to temperature changes or humidity changes as rapidly and as much as other pianos, similar pianos did. So I developed this into a technique that I have subsequently used quite a bit, enough that finally in the early 2000s I wrote a series of articles in the journal, and I went out on a limb and I tried this thinking that, okay, well, this is heresy, but maybe I can, So now it's been used by a number of technicians around the country. I've gotten more feedback on it. And mostly it has worked. In the few cases that I know of that the results were disappointing, is because they didn't follow directions and did something other than what I recommended in the articles. So I decided to revisit those articles here a little while back, and I'm rewriting them now and getting ready to republish them. But I also changed my process just a little bit. And what I have here, so what we're doing when I put the epoxy on the surface of this panel, it soaks in, it saturates, it penetrates the surface, and as it cures, basically what you're doing is you're turning this top layer, and it turns out to be about, depending on the condition of the wood, you're turning it roughly the top quarter of a millimeter to the top millimeter, sometimes a little more if it's a really old punky wood, into a fiber reinforced plastic, which has different characteristics than the wood substrate below it. And what we're actually kind of doing is we're now making it resemble a stressed skin composite. The stressed skin composite has a layer on the bottom, which is stressed one way. It has a core, and it has a surface. So we're kind of moving toward that slowly. And as I decided to revisit this idea and rewrite some of this, I decided to try some different materials. And what I ended up with, I selected 4 different relatively common epoxies, and I'm comparing them in terms of how much mass each one adds to the system and how much stiffness each one adds to the panel. And where is my... Okay, in terms of the process on an existing piano, what you would do is remove all of the original finish from the soundboard, make any structural repairs that are necessary. For example, if the panel is coming loose from the ribs, that has to be glued back down and made structurally sound again. I fill all of the cracks that are open and visible, and if you look at the Kanabi that's in there, you'll notice that I didn't, because when I first stripped the board down, you couldn't see them. And then I wedged the board up and I put the heaters underneath, and I didn't notice, my mistake, I didn't notice that those cracks had opened up until I was well into the job, and by then it was really too late to do anything. So now if you lie down underneath the piano and look up, you can see through those cracked areas. They're filled. There's epoxy in there. They're structurally sound. They're not going anywhere, but it does look a little weird. Fill any cracks that you find. Coat the surface with epoxy. And my original system, I then would recoat. I use a coating epoxy, and I would recoat a very, very thin layer over the entire board. That adds stiffness. It also adds mass. So this time around, I decided, well, let's see what I can do without adding the mass. So on most of these panels, I have scraped off the excess epoxy before it cures. Don't worry about hairline cracks if you're going to do this. You'll find them soon enough. When the epoxy is painted on, you will frequently see little lines across where the epoxy is soaked in and left. Oh, well, and so you'll go back and you'll brush over those, and sometimes you'll see more. And you look at that area to begin with, and you won't see a crack there. It's not visible. But once this stuff, the epoxy penetrates pretty well, and it will seep in there, and it will absolutely seal those things. So. And then once it's cured, you can sand it down flat. And this stuff, all coating epoxies cure very, very slowly. You'll need to leave it for at least 7 days, depending on temperature. It might actually need longer than that before it's fully cured. And then you sand it down, and then you finish it. Technically, you should finish it with something that has a UV blocker in it, because most epoxies can break down somewhat under direct sunlight. Now, obviously, the piano should not be exposed to direct sunlight anyway, but I think we've all seen pianos that are exposed to direct sunlight. So my practice is simply to brush on a coat of exterior marine varnish, which contains ultraviolet light blockers. And it's the ultraviolet light that's the problem. So I've modified that system now somewhat. And in the rewrite that I'm doing, I recommend both, but for different reasons. In some cases, I am now letting the epoxy cure partially until it's cured enough that no more is going to penetrate the surface of the wood. Then I scrape off all the excess, right down to the wood. Then I let it cure 7 days, then I sand it, and then I coat it. And I'll get to what that does right here. And what I then did, I did this. My little test fixture here, just a little frame and that holds this up. These little end pieces are just weights that keep it down so it doesn't squirrel around on me. Then I put my digital indicator underneath it, zero it. Then I put a 1 kilogram load on top and wait until it stabilizes. And I did this with all of these panels. I did it before I put any finish on. And I weighed them, and I put I both weighed them and I put the load on and measured deflection. Then I coated them, did whatever, let them cure for about 2 weeks. Then I I weighed them and I measured deflection. And I was surprised at some of what I found. I included two different types of epoxy that I'd never worked with before, but which I thought were going to give me really great results. One of them is called Total Boat Penetrating Epoxy, and the other is called West Marine Penetrating Epoxy. And these are very thin. They're designed to penetrate. That's the whole point. And it seemed to me logical that the better penetration you got into the surface of the soundboard, the better off we'd be. That seemed logical to me. Yes.
Two questions.
Okay.
So I have one question from Adrian Hamilton again. He said, are you treating the underside of the board too?
I am not. I used to many years ago, but I no longer do that. And I haven't found that the results are any different. But the reason I'm not is that the ribs are already there. And what you're doing is you're changing it from a roughly 2-ply system to a 3-ply system. And treating the bottom of the soundboard is really superfluous. I did it for a while, and then I stopped, and I couldn't really determine that treating the bottom actually did anything. It was difficult to do, very, very time consuming, so I no longer do it.
All right. So that was kind of a fun one. We got to a little bit of a overlap between the two. Whereas that could, where Dell could refer to, some of the other information around using epoxy on soundboards. I see we have a couple extra people rolling in. It does look like we had some type of glitch with the email going out today. It looks like I was able to get some of you who had glitches last week on because I sent you direct messages. So glad that happened. But then today, the majority of people are not getting the link. So I guess there's something wrong with our email server, and we'll have to look into that. So apologies again. But yeah, I'm glad a few of us could join. And of course, we are broadcasting the full thing out on YouTube on a couple of channels. So be able to review the session. And of course, it's in our member area. The full lectures are if people want to check them out. Let's get on to the next clip I wanted to share. This is another one with Dell talking about piano design in general. And we'll hop right into that one, and then we'll wrap up for the day.
Just before we took our little break, somebody here had a question. Ryan.
Right. So you're talking about average string tensions in your design here, and are you able to maintain that? I think you were saying 150 pounds.
Yes.
Are you able to maintain that all the way down to
Yes.
the lowest tenor note?
Yes.
Okay.
And the reason I'm able to do that is because the sweep of the bridge is consistent. And if you remember back to the other design, I showed you how the low portion of the bridge curved around. Now, that particular piano had been redesigned in the 1980s, I think. And originally, that hook, what's called foreshortening, had steel strings on it. And the tensions dropped way down. And in extreme cases, those can drop to probably 60 to 70% of the tension of the notes higher up. And those are impossible to voice. They're also impossible to tune, but they're impossible to voice. There's nothing, there's no combination of things you can do to the hammers to correct that.
One thing that's been on my mind for a long time with those, just tuning, just because I don't understand design, I thought this is a good question for you, is when a string is at lower tension, does an incremental change in the tuning pin result in a larger pitch change? Because it always feels like those last notes are real finicky, like you barely touch them, and they also seem to be the most out of tune when you come to them after a humidity change. I was wondering how much of that relates to the tension on those strings, or is it something else?
Well, I think that it's not something I've studied extensively. I think that some, at least, of the tuning variation or the pitch variation with changes in humidity can be explained by the fact that the tensions are low. You're getting close to the end of the bridge. So the end of the bridge effect comes in. It's more easily moved as the soundboard takes on and loses moisture. And the clamping effect of the backscale is lower because the tensions are lower. It's not as stiff a spring holding it in place. And that's all that comes to mind right now. All right. Speaking lengths for the lowest bass, for the bass strings, again, we're back to that nasty word compromise. You'd like the bass to be as long as possible. And when I first started attending music trade shows, there was a directory that was available called the ANCOT directory. And one of the characteristics, one of the specifications that this directory listed for every piano was the speaking length of A1. And the implication being that within a given size of piano, the longer the speaking length, the better the piano. So why then would I deliberately shorten the speaking length of a bass scale? And that goes back to our compromise situation, that the longer, well, first of all, the bass scale, the bass strings have to fit within the confines of the rim of the cabinet. So we have to provide space for certain things. We have to provide space for the tuning pins. You want to be able to actually get your tuning pin hammer on the strings. You don't want to run into the next door string. You don't want to run into the end of the plate. You've got to be able to tune the piano. So then you need space for what's called the front string frame or plate flange. You need space for the stretcher, the key cover, the keys, key slip, and any molding trim that's up there. So all of those things are givens that you can't take away from those. There's certain minimums that we have to account for. So that's going to limit where I can put this A graph right here. I can only go so far forward, and I can only go so far to the left. In the back, what did I do? Oh, I just put in some numbers. The distance from the A graph to the tuning pin in a short piano like this is going to be somewhere in the vicinity of 55 to 65 millimeters. Why not less than that? Well, you've got to be able to string the piano. And if you get much less than that, the stringer can't get the string up and get the string through the hole in the tuning pin and get it twisted and then get it actually driven into the hole. So it's a practical limitation that we can't practically put that pin the tuning pin any closer to the A-graph than that. All right. From there to the front edge of the string frame, again, the practical minimum is going to be somewhere around 25, 30 millimeters. That means that from the A-graph back here to the front of the stretcher is going to be 93 millimeters. And again, that's kind of a fixed quantity. You just the physical constraints of building and tuning and servicing the piano really don't let you do much else, much other than that. You can make them wider, you can make them further apart, but then you're kind of defeating the purpose of the short piano.
All right. And it looks like we're going to have to cut it there. But I always enjoy spending time with Del Fandrick. What a sharp guy. He alluded to it there in that segment. But, you know, the issue with pianos in general is just a bunch of compromises, or design in general. And I don't know that he mentioned it in that particular clip, but it's also like the less and less of a budget you have for a piano, the more compromise you have to make. We were just dealing with a piano, which I think almost everyone has seen this issue that happens over and over again, is on an upright piano, especially on spinets, on the break between the bass section and the treble section, that very first treble string usually has a dampering issue and some type of ringing that happens because you can't quite fit the bass string that's overstrung over the treble string, and then also have enough space to put the damper in the appropriate place. Just one example of kind of these corners that we run into when we're trying to make a bunch of different compromises in designing a piano. And I've learned over and over again, Del is a guy that really thinks deeply about those type of compromises, and he has the the perspective of technicians and players and a lot of different parties in mind when he thinks about that stuff. So great to see that. I will grab some links that I have. Actually, I'll grab a bunch of links for these. And then, oh yeah, by the way, today's secret word is going to be boo, B-O-O. All right, so if you email me, ethan@pianotechniciansmasterclass.com, or just reply to one of my emails out there, tell me you know the secret word boo, I will send you a discount code if you wanted to either subscribe to one of the masterclasses that we sampled today, or even subscribe in general to one of our ongoing monthly subscriptions with access to the library. So again, I'm sorry we couldn't have a wider audience. This is going on socials. This does apply to people on socials. We'll make it applicable for a week. We'll make it till next Saturday's radio hour, if you message me before then, that we can get you that discount code. So beyond that, though, let's make sure and wrap up on time so that everybody can get on with their days. And just say we've reached the end of another musical journey here at Piano Tech Radio Hour. And thanks to everyone who was able to join us today for jumping on, as well as Del for the wisdom that he's provided over the years and contributed to our content. As always, we're brought to you by Piano Technicians Masterclasses, cutting edge instruction for piano industry masters without leaving your home. For those of you that joined us today by signing up for this session individually, you can make your life more convenient by subscribing to Piano Tech Radio Hour. It's just $16 a month. You get the recording of today's session in our member area, as well as automatic registration for each week's new session. You can sign up at pianotechniciansmasterclass.com/PTRH direct access. All right. I hope you all have a wonderful day, and thanks for joining us.